Now, let's show that the tangent inverse function, whoops, sorry, seems to be an issue, yeah. Let's show that the tangent inverse function is equal to the sine inverse function if given the right circumstances. Now, we have to show that the tangent inverse of 5 by 12 is equal to the sine inverse of 5 by 13. Now, let's see how. Basically, sine inverse 5 by 13, let's give it a value equal to a constant called alpha, right? So when you take this sine inverse function to the right hand side of the equal to sign, you get sine of alpha, right? Because that's just the rule. So sine of alpha is equal to this value, 5 by 13, right? So now we know that tangent alpha is equal to sine of alpha over cos of alpha, right? Cosine of alpha. So we can replace this cosine of alpha with under root 1 minus sine square alpha. How you say? Well, you remember this trigonometric identity, that sine square of x plus cos square of x is equal to 1, right? So when you take this sine square of x to the right hand side, it becomes minus sine square x, so 1 minus sine square x on the right hand side, and then you take the under root on the right hand side to get cosine of x, right? Which is why cosine of alpha is equal to under root 1 minus sine square alpha. Now, replace the sine alpha values in this expression, right? So we already know that sine of alpha is equal to 5 by 13. So this in the numerator becomes 5 by 13, and this sine square alpha becomes 5 by 13 whole square. So now do all the calculations, and you eventually end up with 5 by 12. So tangent of alpha, right, is equal to 5 by 12. Now you can take this tangent function to the right hand side, where it becomes tangent inverse. So alpha is equal to tangent inverse 5 by 12. And so we already knew that alpha was equal to sine inverse 5 by 13, and now we've proven that alpha is also equal to tangent inverse of 5 by 12. So you've proven the equation.